Okay, today we're going to do Objective 10. We are going to write exponential expressions in radical form and vice versa. So we're going to take them from exponential to radical. We're going to take them from radical back to exponential. Then we're also going to take a look at how to simplify exponential and radical expressions. All right, example 1. We're going to write x to the 1/6 power in radical form. Now, like I said, we've already talked a little bit about this. We're just going to put the stamp on it and make it official today. So if we had, let's say, the 4th root of a to the 12th, what do we divide by always? In this case, by 4, right? We always divide by the root. Okay, so that's what I want you to remember. So you're telling me normally this would be the same thing as saying a to the 12 divided by 4, right? We divide by the root. Same thing over here. So what root are we referring to when it is x to the 1/6 power? This is the 6th root. So your denominator is your root, and this is x to the 1st power. Okay, so your numerator is your exponent. And that's it. I need you to understand that in exponential form, it is known as x to the 1/6 power, but that is the same thing in radical form of saying the 6th root of x. Does everybody understand that? Okay, so what form is the second part in? What is this? The 4th root of z. We would call that radical form, okay, because it's using a radical. And I want you to write it in exponential form. Anybody have any thoughts as to what it would be in exponential form? Z to the 1/4 power. So I agree it has a 1 right there with it. So the 1 is the exponent of the variable, and you're dividing by the root. So it would be z to the 1/4 power. Easy? So why don't you try example 2? See what you come up with. So what do you think about the first part? X to the 7th 4th power. 7/4 power. That's an exponential form because it's written using an exponent. How would I write it in radical form? What would one way be to write it? Very good. The 4th root of x to the 7th. Awesome. So I could see this on the SOL, them giving you x to the 7th 4th power, and it says, please choose all of the following that are equivalent, okay, that are equal. So you could choose the 4th root of x to the 7th. Anybody have any other thoughts as to maybe another way you could do this to make it equivalent? Simplify it. Yeah, we can simplify this. So you may see this. I just need you to be able to recognize what you're looking at and what you're seeing. So we could simplify this. What's the highest multiple of 4 that goes into 7? 4, right? So x to the 4th times x cubed. And then when we take x to the 4th out, what do we have on the outside? X. What do we have on the inside? X to the 3rd. So I could see this and this and this being on your SOL, and they could give you any of them and say which one's equivalent to it. Okay, and they're all equivalent to it. Any questions on that? Very good. How about the second part? It's written using a radical. How could we write it using an exponent? C to the negative 5/3 power. I agree. Now, there might be something else you might see. Do you guys remember? I'm going to throw it back to Algebra 1. Do you remember anything about negative exponents? You can't have them. You can't do something a negative amount of times. Do you remember what we do? The magic mirror. Who said that? Very good. Magic mirror. So you make it a fraction, then you can take the base and the power through the denominator and make this 1 over c to the 5/3 power. When it goes through the magic mirror, the exponent becomes positive. Okay? Whether you called it the magic mirror or not, if you didn't have me, you probably didn't call it the magic mirror. Okay? You just move it through the fraction bar. But how many remember that property? Yes? Okay. So it sounds familiar. And second block said, do we have to do that? And I said, no, you don't have to. But I want you to understand that if you saw this on your SOL, that you may see that. But what if you don't see that? You better be able to recognize that it goes through the fraction bar, that you generally do not have a negative exponent. Just as a review of Algebra 1, if I have 2 to the negative 3rd power, can I multiply 2 a negative amount of times? And you know the number one mistake? You can't do that. You can't do 2 times 2 times 2 times 2 times 2 a negative amount of times. Number one mistake is people say, oh, that means negative 2 times negative 2 times negative 2. Are we multiplying negative 2, or does that say to multiply 2? It doesn't say anything about negative 2. It says to multiply 2 a negative amount of times. And you just can't do it. So what you do is you move it through the fraction bar, and you make this 1 over 2 to the 3rd. Now, can you multiply 2 to the 3rd? And so what would your final answer be? 1 over 8. Does that ring a bell? That is a property of exponent that you should have learned in Algebra 1. It definitely was probably on your SOL. Okay? So just as a little refresher course. All right. So everybody shuts down on a problem like this. Why? Because it's got more than one variable and it's got several pieces and parts. But it is the same exact thing that we just covered. What? Yeah, they're all side by side by side, but I just want you to write it as a radical. Okay, I want you to write it in radical form. So, using what we know from examples 1 and 2, how would I write this as a radical? What's the root? It's a cube root of what? A squared b to the 5th. That would make a 2, b to the 5th. There we go. It's a b. Okay. So the cube root of 2 to the 1st, a to the 2nd, b to the 5th. That's one way that you may see it written. Taylor, what would be another way? Then you would have to write them like separately. Does that make sense? You'd have to, like, I don't know, write the 4th root of this times the 3rd root of that times the 7th root of that. But I don't know that you would ever see them. Normally, they all have the same denominator because in Algebra 2, we just want you to recognize that when you write it as an exponent, that it's the same thing as being divided by the root. So normally the roots will be the same. But, yeah, I guess you could just write it separately. Can anyone tell me another way you could write this or something you could do with this? Well, what are we going to do with it first? we're going to simplify the b. So we could go further with this. So you need to recognize that they may stop there. The issue that my students generally have on an IE test or an SOL test or whatever kind of test, they say, Ms. Corns, I don't know, like, do I simplify it? Do I write it as an exponential form? Do I write it as radical form? Like, what am I doing here? And you're going to need to be able to recognize that they may just take it and transpose it into radical form and just leave it. Does that make sense? They just don't simplify it. And then they might take it further and simplify it. You just need to be able to say, oh, well, that's just the same thing as that because all I did was this, that, and that. Okay? So the cube root of 2a squared, and then Rhea, what does my b to the fifth break down into? B to the third and b to the second. And then I can take out a b to the third. So what's my final answer? B times the cube root, 2a squared, b squared. So you may see this as well. Like I said, I mean, I have no clue as to what's going to be on the SOL, but I would venture to say, like, I could, as a teacher, as an educator, I could see them giving you the first problem and saying, click all of the following that are equivalent to that. And then I could see them throwing in things like this. 2 to the 3 over 9, a to the 2/3, b to the 5/3. Is that the same thing? Yeah, why? You can just simplify this. You know what I'm saying? Like, I could see them throwing all kinds of stops at you, but you just have to look at each one and say, oh, well, that's the same thing as that. So, yes, that's equivalent. That's equivalent. That's written in radical form. Oh, that's simplified radical form. So you have to click all that, apply. Okay? All right, how about the bottom one? How do I write it? It's written using a radical. How do I write it as an exponent? Who's got it? What's easy you got? You're right. And? Very good. Any questions about that? Everybody good? Going once, going twice. Sold. All right, last thing we're going to look at. I'm going to show you the easy way, and I'm going to show you the technical way. Okay? If it were me, what would we do to evaluate these? Like, and you wanted to do something, if this were the SOL test, what would you do immediately? Yeah, I put in my calculator first. The very first thing I do is put in my calculator. So, does everybody know how to put in 81 to the negative 1/4 power? You know to use the caret button? Okay, so 81 to the negative 1/4 power. It's 81. The little caret button looks like that. I believe it's above the division sign. Okay, it's below the clear button. And then raised to the parentheses, negative 1 divided by 4. Okay, and then hit enter. So what do you get? Okay, so you get 0.333333. What do you need to do with it? Math, enter, enter, 1/3. That's what I would do with it. Now, I am going to show you how to do it by hand. What if it doesn't come out to be perfect? Then you're going to have to do it by hand and do a factor tree and all of that. Okay, I'll show you how to do that in just a second. Okay? How about 216 to the 2/3 power? I put it in the calculator and I'd make it 36. Okay, so if it comes out to be a whole number or an integer or a fraction, you know, just put it in your calculator and see what it is. But if it comes out to be an irrational number and you know it's not going in perfectly, then you're going to need to break it down. So we do not know how to simplify exponential. So what do we need to do? Take it to radical. We know how to simplify radicals. We did that all week. That's what we've been doing all week, right? So how would I write 81 to the negative 1/4 as a radical? And first of all, if it's a negative 1/4 power, what do I need to do with it? Okay, I need to put it down in the denominator first, right? I need to make it positive. Okay, first thing I need to make it positive. So write it as a radical for me. Who can tell me? What root? It's the 4th root of 81. So what was, just in case, because I think there's one on our game today that's not perfect. You know, if you can put in the 4th root of 81 right now and see that you get 3. And so there's where you get your 1/3 from. Okay. You could take it and you could factor tree it down. So how many groups of 4? One set of 3. So a 3 comes to the outside. So what's in the bottom? A 3. Does that make sense? So you could take it and factor tree it down. So if you can get it in your calculator, great. Get it in your calculator. Try it out first. But if it's not perfect, then put it into radical form and simplify it like you know to simplify it. Okay? So same thing here with 216. You could put it into radical form first. Do I need to move this one to the denominator? No, he's fine. He's got a positive exponent. He's fine. So what root is this? This is the 3rd root of 216 squared. Well, then what is 216 squared? It's a really big number. $46,656. I was trying. So, and then you could factor tree it down. Now, I'm not going to make you factor tree it down right now because that'd be like the one we did yesterday, right? That was like, but it's doable, right? Could you factor tree that down and circle groups of 3, right? And when you did that, it would come out as a 36, okay? So just in case it's not perfect, the way we do exponentials is we don't know how to simplify exponentials. So if you need to do it by hand, take it to radical and then simplify it. Any questions on that? All right, so here's what I'd like for you to try real quick for me. Try those 7 problems. If we're good to go, then we'll get into our activity.